The Henderson-Hasselbalch equation is a super cheap shortcut for buffer solutions, and normally I don't teach shortcuts, but this one's really useful. I'll show examples of how to calculate with it in other videos, but for right now I just want to do a quick derivation. The advantage of it is it lets you find the pH of buffer solutions without using ice. Alright, so that's our goal, the pH of buffer solutions, which is not terribly difficult, but it's more work if you use ice. So this allows us to do it without using ice. Typical equilibrium setups. Alright, the two equations we need to know starting out are that pH is the negative log of our concentration H+, and also that pKa is the negative log of Ka. Alright, so if we look at a pretty straightforward equilibrium system for some generic weak acid, just say you have something like HA we got the double arrow. I encourage my students to always write in the K equation right away. In this case we've got H3O plus over HA. Whatever that value is, this is just some generic acid HA. Now, if we want to derive this Henderson-Hasselbalch equation, what we need to look at is H3O plus relating this thing right here to this thing right here, the pH, and then relating this to our pKa. Alright, so I'm just going to rearrange this K equation. I'm going to say concentration of H3O plus is going to be equal to concentration of HA times Ka over concentration of A minus. Alright, now I have H3O plus by itself, and I would like to turn that into a pH, and I can do that by taking the negative log of that number, and that's okay as long as I do the same thing to both sides. Alright, and in this particular case then, we end up with pH equals the negative log concentration HA Ka over concentration A minus. Now, if you know some basic ideas for logarithmic operations, when you have multiplication and division within a parenthesis, that can become addition and subtraction outside of the parentheses. So I'm going to isolate this Ka, and we can say then that the negative log of Ka plus the negative log of concentration HA over concentration A minus. Alright, and we know that the negative log of Ka is pKa, so I can take this and substitute it in right there, and we end up with pH equals the pKa minus the log concentration HA, over A minus. And we can simplify that even more. Like, it's a common thing to get rid of negatives when you have equations like this, and an easy way to do that is to flip the inside and the outside of the logarithmic expression. So we can then turn this into pH equals a new marker our pKa plus the log of A minus over HA. And you'll notice I dropped out the concentration part of that A minus over HA. If they're in the same solution, the volume part will cancel out, so you can plug in concentrations, that's fine, or you can just plug in molar amounts, that's fine. So this equation here saves us a whole bunch of ice, and it's based on our original K expression and the idea that the pH and the pKa have these logarithmic relationships.